Hello everyone. In this video we are going to discuss about chemical engineering GATE 2018 chemical reaction engineering questions with solution. GATE 2018 question paper and answer key link is available in my description box. You can download it. Question number 15. So here liquid phase isomerization of orthosilane to parasilane using a zeolite catalyst was carried out in a CSTR or MFR. Three set of kinetic data at a different temperature and its stirring speed were obtained as shown below. So here different temperature, different stirring speed, different reaction rate of three set of kinetic data, set A, set B and set C. The operation condition at which the reaction rate is not controlled by external mass transfer resistance. Okay, so this is a condition not controlled by external mass transfer resistance. We have four options. So answer for this question is option A. I am going to explain how is it. So data. So here we have three set of kinetic data, set A, set B and set C. So different temperature, stirring speed, so reaction rates are given. Objective of this question is to determine the reaction rate is not controlled by external mass transfer resistance. Which reaction rate? We are going to find out in solution part. So stirring speed increase, reaction rate increase mean this is governed by mass transfer resistance. Stirring speed increase, reaction rate does not change. This is governed by intrinsic rate reaction. So one by one we could check the option 1. So option 1 already I said this is the correct option for this question. How? So the option 1, temperature 500 Kelvin, RPM is a 3000. Refer the table. So the temperature is a 500 Kelvin. So RPM is a 3000. So here increase the RPM 1000, 2000, 3000. What about the reaction rate? First one is a 0.020, second one is 0.025, third one also 0.025. So the increased stirring speed. So reaction rate does not change. This condition is governed by intrinsic rate reaction. So this is the correct option. What is the meaning? This reaction rate is not controlled by external mass transfer resistance. So that's why this is the correct option. So we could check other option also. What about the option number 2? So option number 2 here. So temperature 600 Kelvin. What about the RPM? RPM is 1000. So here, so temperature is 6000. Speed is 1000. So what about the reaction rate here? 0.037, 0.047, again 0.047. So here the increased stirring speed. What about the reaction rate here? Reaction rate also increase. This is governed by mass transfer resistance. So this is not the correct option. Okay, this is the wrong option. So what about the third option? So third option here. So option number 3, temperature 700 Kelvin, RPM is 1000. So this is correct option or not? So here refer the table. So stirring speed is 7,000, 2000 and 3000. Stirring speed increase. What about the reaction rate here? Reaction rate also increase. 0.06, 0.7, 0.8. So stirring speed increase, reaction rate increase mean this is governed by mass transfer resistance. This is not the correct option. So what about the fourth option here? So fourth option, so temperature 700 Kelvin, RPM is 2000. So refer the table here. So in this table, so the temperature 700 Kelvin, stirring speed increase. What about the reaction rate here? Reaction rate also increase. So that's why this is governed by mass transfer resistance. So this is not the correct option. Option 4 and option 3 is not the correct option. So among these, option A is a correct option. Why? Because stirring speed increase, reaction rate does not change. This is governed by intrinsic rate reaction. So meaning of this reaction rate is not controlled by external mass transfer resistance. So that's why answer for this question is option A. So the option A is a correct option. Temperature 500 Kelvin, RPM is 3000. Are you clear? Yeah. Next question. So question number 21. For a chemical reaction, the ratio of rate constant mean K1 divided by K2 at 500 Kelvin. 500 Kelvin mean that is a T1. To that at 400 Kelvin, that is T2. K1 by K2 is equal to 2.5. That is a ratio of rate constant. Given capital R, this is the gas constant. 8.314 joule per mole Kelvin. The value of activation energy in kilojoule per mole. So objective of this question to determine the activation energy. So we have 4 options. Option C is a correct option for this question. I am going to explain how is it. Data. Here T1 is equal to 500 Kelvin. T2 is equal to 400 Kelvin. K1 by K2 is equal to 2.5. Capital R is equal to 8.314 joule per mole Kelvin. Objective of this question to determine the activation energy in kilojoule per mole. Solution part. By using Arrhenius equation to determine the activation energy with the help of this data. So Arrhenius equation K is equal to K0 into e power minus e by RT. For first one, K1 is equal to K0 into e power minus e by RT1. This is equation number 1. So second option, K2 is equal to K0 into e power minus e by RT2. This is second equation. So divide equation 1 and 2. K1 by K2 is equal to K0 into e power minus e by RT1 divided by K0 into e power minus e by RT2. Which one is a cancel here? K0, K0. This is a common term. So e power minus e by RT1. So divided by e power minus e by RT2 na. This is goes to numerator part plus e by RT2. So here K1 by K2 already given 2.5. This is a ratio of rate constant. So in RHS side exponential of, which one is a common term here? So minus e by R, take outside. So this is 1 by T1. 1 by T1 into minus e by R minus e by RT1. Minus of 1 by T2. So minus into minus plus na here, plus e by RT2. So that's why exponential of minus e by R into 1 by T1 minus 1 by T2. So here 2.5 is equal to exponential of minus e by capital R is given, substitute 8.314. So T1 and T2s are given. T1 is a 500, T2 is a 400. Substitute. Find out the capital E. So here RHS side exponential term is there. Remove the exponential. What do you do here? So take ln both side. Ln of 2.5 is equal to. So here exponentials are cancelled, minus e by 8.314. So this term minus 0.0005. So finally capital E is equal to 15,271 joule per mole. But we want in kilojoule per mole na. So the 15.271 kilojoule per mole. This is the answer. So our answer for this question is option C, 15.2 kilojoule per mole. Check the answer here. Yeah. So this is 15.2. So this is the correct option for this question. This is a 15.2. Am I clear? Okay. So here answer for this question is option C, 15.2 kilojoule per mole. Are you clear? So for further related videos, you can like, share and subscribe my channel. Thank you.